guess I can. All right, great. Thanks very much, everyone, for coming to the first session. So it's going to be led by James, with Amy and Marion involved as well. And it's introduction to Git and GitHub. So over to you, James. And we've got a roving mic for asking questions. You know, we're not streaming this or anything. We're just going to record it for the YouTube channel. So if you want to ask a question but you don't want the question recorded, then don't take this. But if you're happy for it to be recorded, then grab this and I can try and get it to you. Yeah. Okay. Thanks.
Okay, bro. So first thing to ask, did anybody have any issues with the prerequisites? Setting up a Git on their local machine, setting up a GitHub account, connecting the two of them? Is that all? You're all ready to go. Absolutely brilliant. Okay, so today we're going to cover introducing you to Git and GitHub. This is the reason that we're doing this is, one, it's a foundational aspect of software engineering, being able to use version control systems. And because of that, you're going to be using it throughout the summer school. Pretty much every session that you might attend, someone's going to ask you to, oh, Dom. Oh, do I just need to? Someone's going to be asking you to download something from GitHub. So what we want you to get out of this session is basically be familiar with the foundational building blocks of Git. So this is going to be working with repositories, commits, branches, all this kind of basic stuff. Getting started with using Git locally for your own projects, so understanding all the commands associated with that. And then we're going to touch on collaboration as well. So how do we use GitHub, which is an entirely separate thing to Git, but which relies on Git at its core, to start working in a collaborative manner. So we're going to explore forking. There was discussion of merging, and you're going to basically put in pull requests to push some code back to an original repository. And all these things should basically set you up for working with people, working on your own, working with other people. And we want you to take away from today just an appreciation of how useful Git is. When you first start to learn things like Git, it can feel a little bit like, you know, I don't really need this. I'm fine just writing text files and things. But what we want you to take away is an appreciation of how useful version control can be. So have any of you used any kind of version control already? Is anybody using Git, or have you used other tools, Subversion, Mercurial, that kind of thing? A little bit, a tiny bit, okay. So I guess none of you have actually used Git or GitHub yet. If you're not using Git, you won't be using GitHub. And who's already interested in doing better version control? Like, are any of you sort of thinking, you know, I definitely need to be using version control already in my project, and that's why you're here today, or you're here because it's fairly mandatory to attend? Okay. So basically, the reason that tools like Git and GitHub exist, Git came first, about 2008, 2009-ish, and GitHub came after it. But they exist as solutions to the problem of, like, how do we save, share, and collaborate in structured and safe ways? And this is really useful whether you're working on your own as a kind of an independent contributor, as a PhD student or a postdoc, or whether you're part of a wider team and need to collaborate in a way where you're not messing up other people's work. So why Git in particular? So I mentioned a couple of other tools there. So Git has competitors, and it's largely replaced a lot of them, but there was tools like Subversion and Mercurial, and big companies like Google and Facebook have actually developed their own version control tools. Git is the big one, though, in the open source world. It's really taken over, and it's, you know, it covers most of the market. It's a distributed tool, whereas prior tools had been like centralized ones. By distributed, I mean that when you install Git on your system, your files, your Git installation operates completely independently of anybody else's computer. Prior tools had required your version control system to be located on a central server, and your computer would interact with that central server, or you'd install it on your system. But you can work quite independently with Git, and it's designed from the outset as a distributed system, basically. It's very lightweight, but it has very powerful features. And you'll come to see, I guess, you'll find out how powerful some of the Git features can be, particularly powerful around branching and merging. It's high performance and it's scalable. So although you can use it on, you know, small individual code repositories, it works just as well on very, very large scale code databases. It's got excellent data integrity protection. So one of the reasons that we want to use version control is that we want to store the history of our project over time and be able to go back to it. And Git very well stores all this data. And as long as you don't fundamentally delete the entire repository with all the Git information, you've always got the ability to go back and restore yourself from any point in time. And it's open source, it has a rich ecosystem, flexible, customizable. There's all sorts of ways in which you can extend Git or use wrappers around Git that people have developed. And it gives you really fine-grained control over what you're doing. So in today's course, what we're going to do is we're going to start off by creating a local Git repository. We're going to create a file, and we're going to commit that file. We're going to branch from our main, and we're going to take you through what it means to do the branching process. Then we're going to have a bit more of a discussion about working with remotes, and we're going to fork a remote repository, which means that we're going to take a copy of it and we're going to bring it to our local machine so that we've got our own independent copy. And then we're going to put in a pull request to have our changes pushed back to that remote repository. So don't worry if some of the jargon isn't so familiar just now. As we go through the course, it will start to become a bit more familiar. So a Git repository is a place where you can store your code, your files, and each file's revision history. So typically on a computer, we work within a working directory, and that directory might have subfolders that contain all our work. We might, we have subfolders to organize things into, like things go together. And Git sits within that and can see all of that. So it doesn't just see the immediate folder, but it sees the everything that's within that folder all the way down. The root and where the magic happens with Git is a .git folder, which is a hidden folder within your working directory that sits at the highest level in your working directory, basically. This isn't really a human-readable folder, and if you open it up, you won't see human-readable files that you can go into and parse. Rather, this is where, in Git's own internal way, it records the history and stores it. So we'll go into exercise 1 first off. So basically what we're going to do is we're going to open up the terminal. So hopefully most of you are familiar with working with kind of basic shell commands, but we're going to show you exactly what to do. So if you want to get your laptops out and open up, and I'll show you basically what to do here and talk you through it. So the first thing that you want to do is find a place to work on your computer. I'm just going to work in my users directory, basically. And we're going to go in there, and in the command line, using shell commands, we'll just make a directory. And we use this Unix make_dir command, and then we want to enter that using the change directory command. So I will exit this, and you'll be able to view my terminal. So I'm just going to open up a fresh prompt. And I will make that bigger for you because it's a bit small. Okay, so make_dir intro to Git cd. Oops. Oh no. So, excuse the spelling mistake. Okay. And once we're there, we're going to use the command git init. And this is the kind of foundational command that sets up your Git repository in that folder. And you can see that once we've executed that command, we get a message printed to the terminal that tells us that we've initialized an empty Git repository in our working directory, basically. So now you have an empty Git repository. So have you all followed that and managed to do that?
Anybody has got any questions, either call one of us over or
Yes.
ask in the room.
Yes.
So should we do this like anywhere in our...
You can do it wherever you want. Normally when you open up the terminal, it kind of depends on how your computer's configured, but when you open up the terminal, it'll normally go to your users directory. You can do it on the desktop, you can do it wherever you like, basically. Okay, so I'll go back into Safari.
Also, if it's going too fast, let us know as well. So
Yeah.
if you're struggling.
So sorry.
Oh, don't worry, don't worry. We've just started to cover the basics of setting up the Git repository. So we've put if you're on the Slack channel, we've put the slides in there, so you can go back and look at the slides that we've just covered, or one of the helpers here can help you just with the initial steps if you want.
Slack would be great.
Okay. So ahead of us creating a file and doing a commit, we're going to have just a bit of a discussion about what a commit is. So an individual commit is a snapshot of your work at any particular point in time. You can navigate between commits easily with Git, so it has its own mechanism internally for naming a commit, giving it a unique reference name, which is the hash, and you can easily sort of go back in time, go back in history using that hash. So basically, you can easily navigate between different versions of your work should you require to. Now, the hash isn't based on, it isn't like a numbered increment. You know, commit 1 has some, has a suffix like 01, commit 2 has 02. It's a completely randomized chain. It's 16 digits, like basically long. So the idea is that you get a completely unique hash that isn't directly linked to any of the other ones in your chain of commits. So Git is built in a way to be very efficient, so it doesn't store snapshots of your work. So I guess we've all been in the position where we've been working on a Word document and you want to create different versions of it and you end up with like a dozen different versions in the same folder. That's not how Git works. So basically you have, what Git does is it just looks at the differences between each version. So as you do a commit, it looks and it evaluates line by line the work. And it just basically stores the differences and encodes those in its own way and stores that. So that also makes it quick and also makes it lightweight on your system. Because it's looking line by line, Git works best with text-based files. So things like, which is what makes it kind of exemplary for code files, basically. So if you've got like a Python module or something, it'll look line by line at your code, read it all, look at what the differences are, compare previous and after. Files like binary files, so things like image files, JPEGs and things, it's not able to parse the contents of the file in the same way. So though it can see when you've added them and things, it's not, if you're generating images and saving them, it's not necessarily going to be able to see the precise changes in the images and save those because they're encoded in binary, and Git won't work directly with the binary itself. So that you can put all these things in your Git repository, but you're going to get the most value out of basic text files. Okay, and the commit stores a reference to the parent commit. So over time, as you make multiple commits, you almost generate a trail of breadcrumbs, and each commit will have a reference to the prior commit, and that's how you form the kind of the causal link between all your edits. So committing is a three-part process. First step is that you modify the file. So you go into your working tree, you edit the file as normal, make your changes, save them. Then you have to do a thing called staging. Now, Git needs to understand that it's supposed to interact with that file. So if you just create a new file, Git doesn't know that it needs to watch that file yet. And so we need to do a thing called staging, which is when we instruct Git to start watching that file so that it understands that it's supposed to start tracking that file and understanding that the changes that have been made. And it tells Git that basically you want to include this file in your next commit. And then the final process is commit, and that's the point where you take a snapshot of the files that you've staged. So visually, this means that you have a file that's basically created in your working directory, in the working tree. You then use a command called git add, which we're about to explore, and that brings us into the staging area. And then the final step, to formally record the changes that you've made to that file, that's when we do the git commit. And what this means is that there's 4 states that your files can be in. So your file can be untracked, so it's not staged. It can be modified, so you can make an edit to a file that already exists. But Git doesn't know yet that it's supposed to start thinking about these changes and recording them and preparing them for commit. The file can be staged, and this is the point where Git is ready to commit it, and then it can be committed. So basically, we're going to do an exercise now where we're going to create a file. We're going to fill it with some content. You can write whatever you want. You can make a basic text file. You can write a quick Python module or something. And then we're going to go through the process of staging it using the git add command, and then we're going to commit it. So in Unix, you can create a new file without opening it by using the touch command. So you can write touch and then the name of the file that you want. Now, it doesn't have to be new.txt. It can be like hello world.py or whatever you want to do. And then in my computer, I'll use Visual Studio Code to open it, which is why you've got the shorthand code. And with that instruction, the terminal command will then open up my code editor, and I'll be able to edit the file. Alternatively, in your systems, you should have access to Nano, so you can write Nano new.txt. And alternatively, again, just use your normal GUI system, so you can use Notepad, WordPad, one of these things. It doesn't matter, but just showing you how to do it through the terminal as well. So what I'll do is just I'll do touch new.txt. And so I've now created that. So if I do ls, I can see new.txt in my directory. And then if I do code new.txt, basically my Visual Studio opens up and I can edit it. Now I've just created a basic text file, so it doesn't matter what I do here. It's worth remembering that Git doesn't care about the correctness of anything that you've put in. As long as it's all Unicode symbols, it's absolutely fine. So if you're going to write Python, it doesn't need to be correct Python. So I can just write something silly like do hello world, and that's absolutely fine and dandy. And then I can just shut that down. Oh, yeah. So you might have seen we didn't quite come onto it yet, but the next step after that was to use a git command called git status. So at any point when we're working with Git, we can use the command git status, and what that will do is tell us what's going on in the Git repository at that point. So if we do git status now, so it's telling us we've not committed anything yet, which we know, but we've got a new untracked file. So we went through the process of creating the file in our directory, and it spotted that there's now an anomaly. It's got a new file there which it's not staged, and it highlights that to you. And then in the last line, it gives you this hint of what to do. So nothing added to commit, so nothing staged at the moment, but use git add to track. And so it's giving you the hint that basically the next step, once you've created that file, is to use git add. Okay. So git status is kind of a foundational tool in your armory as a software engineer, basically. I pretty much don't do anything in Git without doing git status afterwards to make sure that I've not made a mistake, just to make sure that everything's behaving the way I expect it to. So what git status does is it highlights which is your working branch. So it tells us here we're on branch main, which we'd expect. It reports the commit status, which we've got none. It highlights any untracked files, and it proposes adding these with git add. So Git's good because it gives you hints on what to do along the way. So the next exercise is going to be to add that to the staging area. So if you've been following, you'll understand that we use git add now to add our file. And so the command to do now is git add, and then with the full stop, that's basically saying any files, any new files, any untracked files, add them and stage them. And then we can run git status again and see what comes out.
So it means you will add. It means it will add all the files in this folder to the Git.
Yeah. So Git, if you just use the git add dot, that's shorthand for saying look at all the files that are available. You can specify individual files. So instead of having git add dot, we could have git add new.txt, and it would pick that individual one and add that to the staged area. But what the git add dot is what I tend to do, because normally I've got 2 or 3 files. It's dangerous. But I'm too lazy to add individual files, like to do 2 or 3. So I prefer to add everything and then delete what I don't need.
On Macs, you might get a DS store.
Yes, we get that. But then I create a git ignore and get them automatically removed. Sorry.
just quickly to everyone who just joined, so there's a Slack channel which is linked from the general Slack channel on the summer school Slack, and that has the slides in there. And all that has been done so far is create a new repository, do a Git init, and put the file in there.
Okay, so if we run git status at that point, again, we get a similar summary of data. It's telling us again, we're working on the main branch, no commits, but we've got changes to be committed, and it's telling us that we've now, our new.txt is now in the staged area and is ready to go. So you can still work on the file at this point, but if you do further edits, you'll then need to restage the file. So any edits that you do to the file takes you back to the unstaged status for that individual file, and then you'll need to re-add it. Okay, and so we'll move on to the actual process of committing. So committing, as we mentioned before, is taking your work from the staging area and making a formal save. It's creating a save point for your work at that point. So we don't just, previously we've just done a command where we say like, git add the specific file. When we commit, we need to add a bit more data because we don't just want to commit the file itself. We want to give a message because someone else might come along behind us, or we might want to revisit why we did the commit. So we can add some metadata to the commit that just adds a bit of a story, a bit of a narrative to the work that you're doing. And it means that because commits are identified by essentially like a random hash, there's no parsable information in there. What the software engineer relies on is the commit messages themselves to say, this is the point in the code that I got to where I made that change, and to understand what the subsequent and the prior changes were to identify at a point in time, basically. So what we do is we do git commit, and then we have this command -m, and the -m basically highlights that you're going to leave a message, and then you add a string to your command line entry, and that's just usually with this command you're just doing a short message that's kind of a greatest hits or a highlights of what's gone into that commit. Okay, anybody got any questions about that at all? Is that all quite clear? Good. So this is what you should see once you've done the commit. We get reporting back. So I talked before about the fact that each commit is identified with I think it's a 16-digit hash. You get the first 7 digits of that reported back. So that gives you a bit of a first look at the unique ID for that commit. It tells you what it's done. It tells you how many operations it's done in the commit. So if you've done multiple files and multiple insertions into files, then it gives you a quick summary of basically, what it's done. So if you run git status now, again, you'll get a similar message. It'll tell you that you're working on the main branch, which for me is useful because I quite easily, sometimes, if I'm switching between multiple branches, I get a bit mixed up, so I find that really useful. And now it's saying nothing to commit, working tree clean. Working tree clean means is that you've got no untracked files and nothing in staging ready to be committed. Okay. So as you add commits over time, you build up a history of your file or of your files or of your whole kind of software package. And we need to be able to parse that in some way. We want to be able to have a snapshot and look at all the changes that have happened over time. The command git log is our window into that commit history, basically. So if you type git log in the terminal now, you'll see something quite similar to this. You're not going to see my name, obviously. You're not going to see that time and date. But this is what you'll get given the full identifying hash for that commit. And it will tell you the file that was changed. Now, what you can try now is making further changes to that file that you created, go through the process of git add, git commit, do it 2 or 3 times, and then do git log, and what you'll see is a string of, you'll see the string of individual commits basically like listed over time. And if you press up or down in the terminal, then you'll be able to start to scroll through them. So just take a couple of minutes just to add a few more commits to your file, and then you'll be able to explore git log in a bit more detail. So what we'll do is move on to just having a bit of a chat about branches. So up until this point, I've pointed out that we're working on the main branch, but we've not really discussed what that is. So when you initialize your Git repository, you automatically create this branch called main, which acts as the kind of the first kind of what's the words I'm looking for? Well, it's your first branch. It's the first kind of recorded, named version of your work. But over time, what you can do is decide to split off from that. So in the same way that branches diverge from the trunk on a tree, you can decide to start to work in parallel. So you can have multiple versions of your work at the same time. And what that means is that multiple people can work on the same files, or the files with the same name, making edits without them actually editing each other's files. So if you create multiple versions which exist in parallel with each other, multiple people can edit those files, and then at some point in the future there's a presumption that you merge back together, and those files get combined and merged back into the common repository, or the common sort of understanding, which would be your main branch, basically. So in technical language, a branch is a pointer to a git commit. So over time, you'll create a file, and then that file will have multiple commits made to it. Each of those commits will have an ID. And when you take a branch, what you're doing is you're saying, this new piece of work, I want to reference back to this single commit at this point in time, basically. And it says, at that commit, I want to include the work that we stored in that commit, as well as all the work that had happened previously up until that point in time. And we have in Git the checkout command, and this allows us to switch between different branches and commits, basically. So what we did, you saw my new.txt. You can imagine we created that here. We did our first commit. You do another commit. And then at this point, well, I could have decided to keep working, doing one tranche of work in those files, and that could stay on main, and I could do further commits. But that branch could also operate in parallel. And the two of them don't interact with each other. They're now parallel streams of work. So though we're using the same file names, they live in the same working directory, Git is able to parse out the differences between them, and by using different references to the commits that have gone previously, keep the two bits of work separate until you want to recombine them. Does that make sense to everyone? Or do you have any questions about that? Good. So what we're going to do is, well, the process is we will have created our new.txt in main. We're now going to create a branch which we can name anything we want. In this instance, will be called my branch. And this would be the relationship between the two of them. And basically, we're going to edit the file that we've previously created. So we can create a new branch using the git branch command. So in this case, we've got my shiny new branch, which will be referenced to our current state. So if you've made 3 or 4 commits, the new branch that you create will be referenced to that final commit that you've made, unless you tell it otherwise. So we can use this branch. You can name it whatever you want. And then after we've created, the act of creating a branch doesn't automatically mean that you start working in the new branch. So if you were to create a new branch and then do git status, you'd see that you're still working in main. So we then have to use this process called checking out, which is a direct instruction to Git to start working in the new branch instead of the main branch. However, we can combine the two operations into one using the git checkout -b, my shiny new branch. So what this is telling Git is that we want to check out a branch, but the branch doesn't exist yet. -b says create the new branch as part of checking out this branch. Okay, and once we're in there, start editing a file, add a few more comments, add a few more lines of text and save those, and then add them and commit them. Okay, so if everyone's mostly kind of caught up with that point, what I'll do is just give you a quick demo. So do Git. So I'm just going to create my new branch, and we've checked that branch out. And what I'll do is code new.txt. I'll open that up, make another edit there. Sorry, I'm not being very imaginative with the contents of my file, but and then we'll just run git status just to show you. So we've modified new.txt, and we do git add new.txt, and then we're going to commit that -m added hello. Okay, so if we do git status, we're now nothing to commit. So we're in the new branch, nothing to commit, working tree clean. If we do open up my so we can see the edits that I made in that branch. What we can do now is go back to the main. So do git checkout main, and if we open up the file, and we can see that the edit's not in there. So now we've got two parallel versions of the same file. Why is this important? Well, if you're working in Python or something, you might want to change the implementation of a specific function, just like to test it. You might want to add some kind of new functionality. You might want to do something experimental. But you might not, until all those changes are checked and are verified, and you've added your unit tests and all this good software engineering practice, documentation stuff, you might not want that to form part of the core code base. So you want these changes to exist in parallel, basically. Likewise, if someone else is working on the same file or turnip files in the same directory, they can create their own branch, and you can both work in parallel at the same time and then merge back in at the same time as well. So this is really useful to be able to work in parallel like this. It also means that if you've got multiple different jobs to do, so if you know you want to make change A, B, and C, each of those can have individual branches. And in software engineering sort of parlance, we might call these feature branches. So we have the main itself, which is our reference point, and then each sort of block of changes that you want to make, which are part of some sort of subset of functionality, you can create a branch representing for those. Keep them separate from each other, so you're not just bundling all the work that you're trying to do, multiple changes all in the same branch, and then merge them in individually. And in that way, you keep your work very structured, you keep it modularized, it's much easier to then debug. And if you've added errant changes over time that have broken something, by keeping the work modularized and in smaller units, it's much easier to go back in time and debug it and find out where the error was and correct it. So this is being able to work in branches like this is a real fundamental aspect of Git, and it's a really useful, powerful thing to be able to do. So, are there any questions on branching at all? Oh, why am I opening code again? No, good. Okay, so we've just discussed switching between branches, and we've discussed the fact that when you go back to your main branch, you're not going to see the edits that you've just made in the new one because they're functionally separate units of code now, although you're working in basically the same working directory. Okay. One last thing to touch on whilst we're discussing branches is that you don't always have to, if you're using git checkout, you don't always have to use the name of the branch itself. So if you do git checkout hyphen, then you'll go back to the previous branch that you're working on. So if you want to switch between main and your working branch, just git checkout hyphen, you'll go back to where you were before, and then do it again, and then you go back to that point. So it allows you to just quickly switch between the two of them. Sometimes branch names can be a little bit long. If you're wanting to make it nice and descriptive, then yeah, it can just be a bit of a pain to type in. So, Having covered branching, we're going to start to discuss ways of working with remote repositories. And so there are two reasons to use, well, two basic reasons to use remote repositories. One is that your remote repository can essentially act as your Dropbox or your Google Drive or something. So it kind of gives you cloud backup of your work. So Git itself on your local machine, if your hard drive dies, it doesn't actually, it's not backed up in any way. It's still just data on a hard disk. So by using GitHub or one of these services, it provides you with a level of backup, and it also opens the door to collaboration and using other people's code as well, because it gives you access to work that other people have done. There are two fundamental ways to access other people's remote repositories. So the first would be by cloning. So if there's on GitHub a repository with someone else's work, what you can do is just directly take a copy of that and bring it to your machine. In the same way that you might, basically, if you had like your cloud Dropbox and then you set up your local drive to basically have access to that Dropbox, it just basically copies everything down. So basically you then just take a direct copy of it. If you're forking, what you're doing is that you're taking this other remote repository, you're taking a copy of it to your GitHub, and then you're going to copy it to your local machine. So there's an intermediate step. The difference with the second approach with forking is that you're no longer connected to the first repository in any way. So basically, when you clone, you take the snapshot of that. But if you were then to go and push changes back to the remote, you'd be pushing back to that original repository. You might not, if it's just somebody else's work on the internet, you might not have access to that. You might not be set up as a collaborator. They might not want collaboration. So in those instances, it's actually better to, it might be better to fork. So. Yes, so I'm starting to get a little bit ahead of myself. So, yeah. So when would you use a clone? Well, you would use a clone if you're in a group of people, you're collaborating directly, and you're using the GitHub as your common reference point for the code, basically. And either you can own that GitHub repository directory, or one of your collaborators does, and they set up the GitHub for collaboration. Or it can be owned by someone else, but you're happy not to have ownership of the code base. So the owner of the GitHub account has fundamental control of what changes might be migrated back in. So cloning might be appropriate if you just want to pull the code down and then only ever use it locally, but you don't have the control to then push it back and in an open source collaborative world, have those changes merged back and for other people to be able to use them. So if you're going to clone and you want to push the work back onto the GitHub, you need to have permission to do so, or the account needs to be set up for you to be able to do that. And it's also, if you're just cloning a repository, it's much easier to have access to the latest changes. So if you clone and then start your work and you're working away, and in the meantime someone else has updated the repo, some work's been merged in, and you think, actually I'd like to have those changes, if you clone, it's much easier to just grab those changes, pull them down locally, merge them in, and continue working with all the benefits of that new work. And yeah, basically, if you're cloning and working with this kind of a central repository, the main branch forms basically the common reference point for you all, and that's where you all push your work into. So forking, on the other hand, be used where the owner of that repository isn't someone that you're actively collaborating with. So someone might have created a repository at some point and you say, wow, that's really good, I want to use that work, but they're not interested in collaborating. So what you want to do is take a snapshot of that repository, copy it to your own GitHub, and isolate it. So you get all the benefits of that work, but you no longer have to actually interact with that repository anymore. Forking might be appropriate if you're not just making small changes, but you actually want to take the repository in a different direction. So there may have been one development philosophy that achieved a certain amount, gave a certain amount of functionality, but you say, well, actually, I can use that as a base, but actually start to go in a bit of a different direction with it. So you might want to call it, if you're forking repository X, you might call it repository X like version 2 or it's beta or something like that. But you're starting to add in changes which are basically instigating a different philosophy or adding new functionality which wasn't part of the original vision for the first repository. And forking gives you direct control, because when you create this new repository in your own GitHub, you're the admin. Automatically, you're the admin of that work. You can invite other people to collaborate with you, and you'll just collaborate in your GitHub, and it doesn't matter what's going on in the original one. It's just that's now completely separate. And by being the admin of that repository, it gives you access to, it basically allows you to control what other people's contributions to the repository become. So what we'll show you in GitHub is there's actually lots of ways to set up controls. It's not a free-for-all, and you can have very limited controls on the repository, or you can have very tight controls on it. And it just depends what level of security you want, what level of quality assurance, that kind of thing for your work. Yeah, and by forking, as I pointed out, you're not going to be getting any kind of updates or the ability to easily sort of directly pull updates from the original repo without some intent by basically, pulling their work across. It won't happen automatically. And the final thing is, about permissions. So if you don't have any permissions from the original repo, it's no point in, you'd want to fork, because any work that you want to push back, you're not going to be able to. So the basic structure that we're talking about is that this Hello World repo exists somewhere on GitHub. You fork it, you create your own version still on GitHub, and then what you do is you connect your local machine to your new repository. So we're going to show you how to fork today, because that involves the process of, well, both one forking but also cloning as well, because we're going to be basically taking this GitHub repository and working with it on our local machine. So we cover all bases. So this requires that you all have a GitHub account, so hopefully it's all set up and ready to go. What we'd like you to do is go to this web address here. So we've created a repository that you can go in and go through the process of forking. Basically, it's a very small, tiny code base which Amy created with a few text files in it. So if you could, in your browsers, head to that location, and I will open it up on my machine.
The link is also in the Slack channel. The link to that repository.
So when you go into GitHub, you'll see someone's repository like this. This is a very basic repo with a few basic features in it. We've got a license file which tells other people like us coming along to see it for the first time what the limitations on our use of that is. So it's really important, if you're going to use open source software, that you check that you legally have the right to access those files and to use those files. Most open source stuff will have some sort of license, like an MIT license, or there's loads of different types of license out there covering all sorts of different possibilities, from do what you want with it to use it but acknowledge us, to all sorts of different constraints on it. So it's just important to double check that if you're going to grab someone else's work. Normally there would also be a README which gives some explanation of how to, if you're working with a language like C where you've got to build code or something, there might be instructions on what to do in there, or any other instructions, useful stuff. So we've got 2 text files in here. You can directly access an awful lot of information about the repository. So if you were to, this is telling us that we're looking at the main branch. So if there were other branches to look at, we could simply go in here and view all branches. So you can see the entire kind of history of the repository. Well, not history, but the current status of that repository at that point in time. And they're in GitHub. It's not just about storing code, but it's rather a project management tool for collaboration. So in a GitHub repo, if we move along basically to the next tab, we have issues. So this is where people can raise issues about the code. So if you want to talk to the code owner about what's going on in the code and point out that something's broken, you can raise an issue and you can basically talk to them, and hopefully, your mileage may vary about how much interaction you get, but in theory, you can start a discussion about some bug or something. There's a pull request tab where you can go in and see any existing pull requests. So this is where people have requested that they can merge their work back into this repository. And then there's various other kind of settings that you can look at over time. You can look at the whole history, who's been committing what when, all kinds of stuff. But what we're going to do is go in and fork it. So we go to the fork menu here, and we're going to create a new fork. So if you want to follow along. So what this tells us is I haven't forked this before, which I haven't. I'm doing this for the first time. And we're going to create a new fork. Why is that so small? That's funny. So hopefully you should all be, if you can't read what's on the screen, you can read on your own one. I'm not sure why it's opened that in such small text. But basically, when you create a new fork, it tells us here that you're going to be the owner. And by convention, when you fork, you often keep the same repository name as the donor repository. You don't have to do that. You can name it whatever you want. But as part of just keeping, the trail of breadcrumbs so you understand where it's come from, often people will keep the same repository name or indicate that it's a slightly different version of it. There's an option that you'll see, so you can copy the main branch only. So if you only want to bring the stuff that's been formally committed and has the kind of status of finished work, you can bring the main branch only. So you don't have to worry about all their kind of development branches and things. If you're going to be taking the code base in a different direction, why are you worried about their kind of work in progress basically in their branches? So you can bring the main branch only, and then basically you hit the create fork button. Oh. That's, create fork. Okay. So now what we're doing is we're in my GitHub account, and we can see that we're in our forked GitHub account, and it tells us that we've forked it from Cambridge ICCS, the Git Intro ICCS Summer School 2024. So, and it's telling us that we're up to date with the donor or the donor repository, basically. So that's exactly everything's as it should be. It's telling us that they're both identical to each other. There's been no changes. What we've done is just take a copy of it. The next step, because this repository doesn't exist on our local computer yet, the next step is to copy it off the internet and bring it to our local machine, and then we can start development work. It is possible to do work in GitHub if you want to do quick edits like hot fixes, but we're not going to do that today, and do that at your own risk. This is slightly different. Marion's not happy.
Every time you do that and you think, I can just fix this little bug quickly, then afterwards all the tests fail because you introduced something.
Yeah. So do so at your own peril. That's something to try at home. So this is basically what we saw. We've gone through the step. We've created the fork. So before we clone to our local drive, what we need to do is make sure that we're not going to, because this already exists as a Git repository, we don't want to bring it into the repository that we've been working in locally. So where I've been created new.txt and I've been working away, if we bring this work into there, then suddenly we're going to have two Git repositories in the same working directory. And unless you set it up properly, they can interfere and break things basically. So by and large, certainly at an introductory level, what you want to do is have one Git repository per working directory. So the first thing that we need to do before we do anything else is basically create a new directory for us to work in. So think back to the start, we used the makedir command. So you want to go back up, go up a level. If you want to put it in roughly the same place, you can do cd ... create a new directory, and then we're going to clone the work into that one. So I will just show you. I'll go into my own terminal and just show you quickly. So I'm currently working in intro to Git, so I'll go up one level. I'm going to make a directory, which I'm going to call intro to GitHub this time. and then I'll change directory intro to, okay.
It must be the empty folder.
Sorry? Yes, it needs to be a completely empty folder that you're going to clone into, or should be,
No, I think you, if you...
for the purposes of this exercise.
Git clone, it will use the name of the new repository as a folder name.
Yes, okay. Okay, so on the slide there, you might have seen already the git command. So we use the command git clone to copy the repository down. Now, what you can do, so what we do is we give the internet address, the URL of the repository itself. The easiest way to do that is just go into your browser, go to your repository, copy it from the browser, and then just paste it into the terminal once you've written git clone. Or you can type it out long form. It's up to you.
Do you want to show, if you go to the repository and show this little button there on the top right?
Ah, yes.
When you go to code the green button,
Yes, sorry, that one.
that one.
Yeah. Thank you, Marion. Yes, so, so basically, one of the things that we asked you to do as a prerequisite was to set up, security. So you set up the GitHub account, as part of setting up the GitHub account, you set up two-factor authentication, and then to be able to work with local repositories, you need to set up a security mechanism, and there are different standards, but we asked you to do the SSH one. So if you copy that's right, yep, and then you can basically go to your terminal, go to git clone, and then paste that in. And I'll press go on that. So once you've added that, put that command in, Git gives you a bit of a summary of what's going on. So the short description of this is that basically the work in the GitHub repository is getting packaged up, pulled down, and then not installed, but added to your local working directory, basically. And then if we do ls, we can see, so ls is the command that allows us to see the files and folders that are within that working directory. We can see within there, we've now got a new folder with the name of the GitHub repository. And then if we go into that, so cd git ls, we can see the files that we previously looked at in GitHub. So we can see the license, the README, and then the two text files. So all of the full contents of the repository, including all the kind of meta files that are associated with the files that you actually want to work on, are pulled down. So what we'd like you to do is go into these files or create your own new files and basically make some changes. So based on what we've shown you already, open them up, make some changes, commit them, and then once you've done a couple of commits, we'll show you what to do next. Now that I've added that change, I want to do git status, and it tells us that we've modified that file, but we need to do git add, and then git commit, -n, and then added definition of flying. Okay, so once we've added a commit, we're now out of sync with the original repository in GitHub, and we want to think about how we get those changes that we've made locally back to our remote, which is our GitHub repository, not the original one that we took the work from. So this aspect of adding the work back to GitHub is known as pushing. So you might have heard the lingo or heard the jargon around Git, so pushing and pulling. Sending changes from your local drive back to your GitHub or to another Git repository is basically known as pushing. So the command that we need to do is git push, and the remote we're going to call the origin. So if I do that, so I've put in, working in my new branch with my edits in it, I've done the command git push origin. Here we go. And this is how we indicate to Git that we want to send our changes in our current branch to our remote. But Git's come back to me and said that actually the current branch has no upstream branch, because what we haven't done at this point is that we haven't linked our local to our remote. And so we need to use this command here first, and this is a one-time thing as part of the setup and the connection of your GitHub remote and your local directory, is that we need to set upstream. So we can do it as one command. We can use git push -- set upstream origin new branch. And what that will do is that will set up the connection and send the changes to our GitHub. And then once we've done that, we can go into our GitHub and we should be able to see our changes there. So I should do that. So Git gives us a bunch of information about what's been going on. It tells us how to put in a pull request. And it tells us that our working branch in our local repository has been set up to track the origin, which is our GitHub remote, and a corresponding branch called new branch. So there's a symmetry between how the remote is set up and how your local is set up. And if we go into GitHub, we can see, we get this nice message at the top here that says, my new branch had recent pushes 2 seconds ago. So it's received the information and it's flagging up that, those changes have been made. And it gives us, and it says to us, actually, you can put in a pull request now. So, and putting in the pull request means that we take what's on the branch, on the working branch, and we add it to main in the remote repository. So if we go into the pull request, okay. So when we put in our pull request, it tells us what we're adding to what. So pull requests don't have to be between a branch and main, but rather they can be between any two branches as well. And these two pull-down menus here allow you to set up which one has the new information and which one is going to receive the information, basically. And you get this message that so GitHub is able to kind of iterate over your changes and sort of do some clever work to tell you whether they're going to be able to merge automatically or not, or whether there's conflicts. If two people make edits to a file, or even one person makes edit to a file, they can make changes which don't naturally propagate into the receiving file. So GitHub can get confused about how one change you made relates to, how it's supposed to basically get added into the new file. This is basically particularly common where you have made substantial changes to a file, or where you've got two people working on the file at the same time, or the file that you used as the base version upon which you made your changes has been edited in the meantime, and those changes have been pulled in. Cool. So we've just got 5 minutes left of the session, so maybe what's best to do is if we do a demo of putting in the pull request to our own repository and then putting the pull request into the host repository, and I'll show you the process of asking for the pull, like submitting the pull request, and then I'll show you what you see from the other side. So the owner of the host repository, what they see when someone puts in a pull request to their work. Oh, sorry, yes, last slide. Okay. So what we want you to take away today is to be familiar with the building blocks of Git, so repositories, commits, branches, and to basically be able to get started with using Git locally on your own projects. We want you to be able to get started with collaborating on code projects using GitHub, and we want you to have an appreciation for how useful Git can be. If there's anything that you want to follow up today, we offer the Code Clinic service. The Code Clinic is about taking any problems that you have, bringing them to us, and just getting some helpful advice on where you might go from there. And it can be from the most minor issues, if you're kind of feeling indecisive about what direction you want to take some code in, how you implement something, we can talk through it with you, up to sort of thinking about planning more comprehensive pieces of rework or adding new functionality. But basically, it's the first point of call with us for getting some support. And from the Code Clinic, we can discuss like ongoing support should you require it, putting in bigger requests for collaboration, or just checking in now and again for, see how you're getting on. You can book, whilst you're here at the summer school, you can book some time with us through the spreadsheet that's already been mentioned. And yeah, basically we're all available over the next couple of days at various points, and you can have some time with us. These courses are going to be made available on YouTube, but there are, all over the internet, there are further resources for keeping on going with Git. There's lots and lots to learn, and this is just one example, but you'll find useful stuff everywhere. So thank you very much for attending today, and hope you enjoy the break, and I hope you enjoy the rest of this afternoon's sessions. So thank you.